Hello everybody, my name is Michael Smith, and today I want to take you through Web Application Firewall internals and really look at how rules are structured and how they work. This is me. I'm an independent consultant. I work in three different core services, three different offerings. One of those is Virtual Chief Information Security Officer for startups. Another one is CTO for cybersecurity companies, especially in the web space or the web or internet infrastructure space. And the third one is a general advisory over things like cyber threat intelligence and national defense. Okay. More relevant to what we're talking today, I spent 10 years working with Akamai, helping them understand what a WAF was, how to sell it, how to use it, how to maintain it. In 2013, 2014, and the very first part of 2015, I was the director of Akamai's incident response team and the world's largest user of the Akamai WAF. So why do you want to learn what a WAF does, right? Really, it's like any technology. In order to understand it, in order to set it up, understand what it's doing, troubleshoot it, and then on a red team sense, in order to evade what a WAF is doing, you need to understand how that engine works. And really inside of a WAF, you've got some utility to configure it, right? So a user interface, some way to get the configuration into the servers or into the appliance, whatever it is, and actually run. You need something that spits out logs, but the real core of it is what are the rules and how does that enforcement happen? And that's really what we're going to talk about today. Now, some WAF rules are really, really easy. They're easy to understand. They're relatively easy to write. Simple things. So one is the URL is greater than 500 characters. I have a war story about that with a customer of mine that I was monitoring, and I noticed that this rule kept firing, and I was like, what? Why is this rule firing? I've never seen that rule ID before, and went in to find out that that particular website had a remote file include that was triggering that rule that the URL was too long, right? So normally URLs that are very long might have a payload inside of them. So that's a common rule. Another one is the user agent is bot. So Google bot, spy bot, search bot, all of these different bots, they come out and they identify themselves as a bot. It's pretty easy to write a rule that says the user agent is something bot. Okay? No host header. So where inside of an HTTP request, you have headers and you have the body of the request. In it, you usually need a host header to tell the web server what website you're looking for. If you don't send a host header, odds are that you're some kind of a vulnerability scanner. Okay? No accept headers, so real users give accept headers. They might tell you what languages they're looking for. They might tell you what kind of content they're looking for, whether it's an image or a text or an HTML file. They'll tell you what they're looking for. HTTP protocol, almost any modern browser today uses HTTP 1.1. Local and remote file includes really, really easy because you have some kind of either a URL or some kind of directory browsing like // you'll see those. Those are really easy to detect. And then things like process flow. So when you request this particular URL, did you come from this other URL? And that's really, you just need a mapping of this page goes to this page, and you just enforce that in the refer from request to request. Some WAF rules are really hard. And I've got 3 examples there. There are probably more that you can think of. But the reason that they are hard is because they have an overlap with normal user content. And we'll go into this quite in depth, especially with SQL Injection, where you have words like table, user, select. These are SQL reserved words, but they're also reserved characters or reserved words in SQL. And you'll also find the same with cross-site scripting, where words like script by itself, maybe that's a user talking about a script because it's Stack Overflow and people talk about scripting there. Maybe it's because they're using the script keyword inside of HTML or JavaScript in order to actually get some kind of script to execute. And you don't really know what the difference is. Okay. And then command injection has a lot of words that overlap because they're operating system words. These hard WAF rules are where you end up with a lot of your false positives and where you spend a lot of your time actually tuning a WAF in order to reduce the false positives, right? In order to not block legitimate users' legitimate requests, and in order to reduce the amount of false negatives. So where you say that a request is okay, but it's actually malicious. That's where you spend kind of that Pareto principle. That's where you spend 80% of your time trying to get these hard rules to be as accurate as they can be. Now, if you look at a WAF itself, a WAF rule usually has 3 core components. It has lots of components around it, but it has 3 core components that make a WAF rule work. And the first one is an object model of an HTTP or HTTPS request, right? So you have IP information. You have all of the headers for the HTTP request. You've got the body of the request. You have the URL. You have the query string. All of that fits into this object tree, and you can look in various places there for particular types of attacks. The second thing is a regular expressions engine. Almost all WAFs operate in some kind of pattern matching, whether it's regular expressions, and there's several libraries that do that, or it's some kind of simple string matching utility, but you have to at least be able to do some kind of pattern matching. And then the last thing is a scoring system that tells you when you've matched enough of what kind, then yes, that actually is an attack. And we'll go over that in the rest of this presentation. So don't get too hung up on that right now. This is the HTTP request object tree. Really what I just want you to understand is some of the common things that you see. So you usually have the request at the top. Even above that, you'll have the TCP IP information. So source IP address, destination IP address, source port, destination port, all of the TCP flags. That's all there, and you can actually use it. Some WAFs expose it, some don't, but at least they'll expose IP addresses and ports. Okay. Then inside of the request itself, you've got the headers, so host, user agent, accept, all of those things that you see. Those, just like a header, they fit at the top of the request. You have the URL itself, which is in the first line, and along with the method, which would be get, post, all of that stuff. And then you have something that's a query string. And the query string can either be put inside of the URL with variables, so it's key value pair, so it's variable and a value, or it can be inside of the body of the request if you use post. But out of that, you get usually 2 things. One is a sequentially ordered array called args. So just like in shell scripting where you have add args, and you have, add args1, args2, or 3. Or you get an array where you have the arguments by the particular variable name that as they were submitted. Now, the key to this is that you can put attacks in various places of this tree depending on who it is that you're targeting. Most of the attacks that you will see will be inside of the query string. They'll be inside of the variable values because those are the things that the application deals with later on. But say if you were trying to target an administrator of a web application, you could put things into, say, the user agent if you know that that particular application administrator looks at their logs, right? So you're really targeting the administrator. It's a different type of field, different type of attack. But as a WAF, you want to check all of the fields that you can to see if that particular field has malicious content. And so really interesting to me is how a WAF iterates through all of these different pieces of the request and checks it for malicious content. Now, life imitates Xkcd, right? And Xkcd is a cartoon. It's made by a guy who has a background in higher math and engineering, and he used to work for NASA. He went to MIT. Very, very smart guy, but he just about everything that he puts in a cartoon happens in the real world. It's just you a lot of times you find something that happens in the real world and you look back and there's an Xkcd cartoon for it. Well, in this case, this is the infamous Bobby tables. Now, what happened here is that there is actually an SQL injection, right? So the whole idea behind the joke is the school calls up a mom, says, hey, your son did something, we're having a problem, and they ask, did you really name your son Robert Drop Table Students, which is the SQL injection? And obviously she comes back and says, yes, oh yeah, little Bobby Tables, that's what we call him. And they lost all the student records, and hopefully the school has learned how to sanitize its input now. The joke being she actually named her child with an SQL injection in their name. I went and extracted the actual name of our little Bobby Tables here, and here's what it looks like. Now, out of that, some of these words are common usage, right? So in that case, you've got Robert, students. The rest of it is SQL reserved characters. Now, if I highlight those, it looks like this. So the way that SQL injection works is you, inside of the application, you do string concatenation, and that turns into an SQL query. And in this case, what you're doing is you're finishing the previous statement with the single quote and the right parenthesis and a semicolon, and then injecting an entirely new SQL statement, which is drop table students, and finishing it off with a dash dash, which means anything to the right of dash dash is going to be a comment, and it will be ignored by the SQL database, whatever that database is. Back in a lot of the early WAFs, the way that they would run WAF rules is you would have one big, huge monolithic rule that would have all of the SQL reserved words. And if you match the request, say 3 times or 5 times against the SQL reserved words and characters, then you'd consider that to be a WAF match, and you would block that request. Well, the problem with that is you run into this gray area where some words and phrases out of this drop in table that are sometimes they're an attack and sometimes they're not. And so if you had a larger request, the larger that form data became, because maybe it was a user contributed forums where you allow 5,000 characters in a post, well, the odds of you having 3 of these words in that form data is very high, right? Especially if you're talking about a lot of different things, different industries or topics or what have you, that also have a lot of overlap with SQL words. That meant that you'd have a lot higher false positive rate, and you would be turning away a lot of legitimate users. And one of the problems with early WAF adoption was that because you had a higher false positive rate and you would block legitimate users, people wouldn't have a high level of confidence in what that particular technology was doing. I took that SQL statement or that SQL injection attack and dropped it into, there's a pun there, we'll get it later, but I dropped it into a Venn diagram, and out of that I get 3 different groups. So you've got characters on the left-hand side, I put them in red. Those are characters that are really unique to SQL, right? Structured Query Language. You have characters on the right-hand side that are common English usage and not an SQL command. And in the center, we have drop and table. And drop and table could be malicious and could be benign, and we don't necessarily know. I took my Venn diagram and added in more SQL specific words on the left, benign common English words on the right, and put more dual meaning words in the center there. So now you can kind of get an idea of, yes, I can group, pretty much any string of characters that's out there on this planet. I can put them into one of these three buckets. Then after I group these words or characters into different buckets, I can assign a score value for each one of these, right? And that score is a function of what's the probability that that particular string of characters is malicious versus not malicious, right? Obviously, this is going to be a lot more nuanced. And so there's a lot of effort there in big data, structured learning, supervised learning to set these scores a lot more finely tuned than how I have it here. This is an overly simplified model. But that score represents the probability. And then I added an overall score threshold where if you add all these up and they exceed that score, then it's probably a malicious request. And this is what that scoring looks like for Bobby tables. In this case, I've got Robert that scored a 0, single quote, parenthesis, semicolon, which is 15, drop table, which are 5 each, because they're kind of iffy in that gray area. Students, which is totally not an SQL reserved word. And then the semicolon dash dash, which is definitely SQL. And I scored that at 15. The total score is 40, so that's probably SQL injection. And you can do this for each of the different type of groups. So SQL injection, cross-site scripting, all of that, you'd have a different score and a group or a type of attack, and have individual scores for each type of attack. Maybe have a total score for the entire request, regardless of what group. You can start splitting it out and making it a lot more modular. What this also means is that tuning a WAF in a world like this, instead of trying to manipulate one large monolithic rule, you're going in and changing the values specifically for the type of traffic that you get. I do have some favorite false positives that we've tuned out before. One of my favorites was a furniture company who said they couldn't use the WAF until it had better tuning because they sell drop leaf tables, and that was a high false positive for them. One of my other personal favorites is command injection that flags on ID, and ID is also the localization code for Indonesia, in addition to being the shortcut for identity. So I'd see that one quite a bit. That one kind of became a favorite of mine when I lived in Asia. And that's it for WAF rules. Hopefully I entertained you and gave you some education. Hopefully you can now go understand what WAF rules are, what they're doing, how to troubleshoot them. As a reminder, I'm an independent consultant. I help a lot of companies, especially if they're web companies, internet infrastructure companies need a virtual security officer, or if they're a vendor that sells anything really web infrastructure, cyber threat intelligence related. Get in touch with me. Love to talk to people. Thanks for watching and have a good day.